All right, good morning, seventh graders. We are working on math lesson 9 today. Before you even begin this lesson, I want you to remember the two equations we already know. Area equals pi radius squared, as well as circumference equals pi times diameter, or diameter times pi. So for this warm up, I would like you, as you can tell, you already have done it, but I would like you to solve for the exact area of our circle. Okay, remember how I did it in class yesterday. Use the equation to solve for the exact answer. When you are ready, or pause so you can do the work, and when you are ready, let's move on. The answer is 500,000, 2,655 meters squared. So that is C. All right. Okay, let's move on to our next question. All right, for 9.2, comparing areas made of circles. Each square has a side length of 12 units. So we know that each square side is 12. I don't know why it's making a box over there. It is 12, okay? That's 12 right here. 12 right here. All right, so compare the areas of the shaded regions in the three figures. Which figure has the largest shaded region? Explain or show your answer. So go through these three and try to figure out which ones you think is larger or small or larger. Okay, remember, we already know the diameter of the big circle is 12 because it's equivalent to the side of the square. Now, if we go to this to box number B, we know the diameter, oops, that's way off. Let's erase that. All right, we know that the diameter of the two circles would equal to 12. But we know half of 12, oh, maybe if I can write, is 6. So the diameter of one of the circles should be 6, which means each one of the diameters is 6. So now if we look at the C, oh, that's a little off too, but that's okay. The diameter then would be 12 divided by 3, and then you have the diameter for each of these circles. Remember, find the area of the square just as you find the area of the circle, and then you can subtract the area of the circle from the area of the square to figure out which A, B, or C has the largest shaded region. Hit pause, please, and we will continue. All right, so just so you know, they are all equal. A, B, and C have equal shaded regions. Mind blown, right? All right, so let's move on to question number 2. So for figures D and E has a side length of 1. So each figure of D and E has a side length of 1. That means our little guy right here is 1, 1, 1, 1, 1. Okay, compare the area of the two figures. Which figure has more area? How much more? Explain or show your reason. Just as we did yesterday, or not yesterday, a few days before, we had the floor plan, which we reconstructed to have a bunch of different squares in it. I want you to look at these figures to see how you can put them together into polygons that you already know. So like for figure D right here, we know that there's probably at least 2 circles in there. We know there's 4 half circles. So if we were able to put in these these circles together, we'd have 2 circles and then a rectangle, or 2 squares. So we also know that the radius of one of these circles is 1, because we know these little squares each had a unit of 1 as their length. Please solve that equation, or please solve for the area of D. For E, try to see how you can put it together. There are multiple circles in figure E. See how you can put it together in order to find the area of objects we know how to find the area of. Hit pause to solve that. And just so you know, figure E has the larger area. So let's move on. We're not doing Are You Ready for More? You can if you would like. All right, so for 9.3, this is the running track revisited. We have already done this. That means we should have a pretty good chance at it. So please find the area of the running track that goes around the field. This is one step farther than what we have done before. Please attempt to use the information we already know. Okay? Again, we know how to find the area of the circle, and we know potentially how to find the area of this whole, what is that? A very long circle. I forget the word for that polygon. Okay, so attempt to find this answer. Use all the polygons and ways to solve it. Okay? If you have any questions, please reach out to me. I hope that sentence made sense. Down here is the lesson summary. Review it. As always, I will give you the answer to this in class on Monday. Please do not forget to do the practice problems for this lesson. If you have any questions, please email me.